Now we begin working with temperature. Using the fundamental ideas we've talked about up until now, we can relate now to differences we should expect to find on Earth's surface. And a very simple question. Identify 4 reasons why temperature varies across Earth's surface. 3 of these reasons we've already discussed. The 4th reason will be the focus of video lecture 2.7. We'll be working with this map here, showcasing global temperature, showcasing temperature. So this is an isotherm map. We have, of course, red being hottest areas, and as we get cooler and cooler and cooler, we move to bluer colors on this map. And going back to what we just talked about regarding net radiation, we tend to have those areas that have an energy surplus, and then those places in energy deficit with those transition zones in between a surplus and a deficit. So the first key temperature control, one that we already know, would be latitude. Of course, latitude affects insolation. Higher latitudes or higher being places closer to the poles, higher number latitudes, closer to 90, have less insolation and therefore lower temperatures at the surface. Whereas those places, the lower latitudes, tropics and along the equator, have more insolation and thus are going to have higher temperature. And so our first key temperature control would be latitude. This is a graph showing different temperature profiles for different places regarding their latitude. Of course, on the top, on the right-hand side, we have temperature, and then, of course, on the bottom, we've got the different months throughout the year. So every single place except one has their warmest month in June, July, or what we would think of as the summer. The only exception would be Salvador, Brazil. And what's going on there? It's just simply in the southern hemisphere. So the southern hemisphere once again is going to have their highest temperatures in or around December, where we tend to have ours June, July, August. That's one thing we can note with this temperature profile. But also, as we go from the bottom, Barrow, Alaska, we have a very northern latitude, a high latitude, where we see a much cooler temperature profile throughout the year compared to Montreal, which is closer to the equator, Edinburgh, Scotland, which is about the same. Then New Orleans, which of course is getting even closer to the tropics, getting even closer to the latitude of the equator. The lower number latitudes, we can see this increasing temperature. Next up, one that we already know, would be altitude. So we learned in a previous video lecture that in the troposphere, as you increase in elevation from Earth's surface, you should see, or you should expect to see, a decrease in temperature. So altitude would be our second key temperature control. A good way to showcase altitude is with our good friend South America. Going back to Map Quiz 1, you should have learned where the Andes Mountains are. And on the left-hand map, this is just a temperature map, and you can almost see exactly where the Andes Mountains are as they go all the way along the entire western spine of South America. One thing we can do is we can compare 2 different cities, one that's maybe at a higher altitude that's relatively at the same latitude as a place at a lower elevation, which we'll do with 2 cities here, La Paz and Concepcion. Essentially at the same latitude. There's really no difference there, but one of the things you'll notice on the following images is a pretty big difference as far as their temperature profile. Concepcion is shown as the red temperature line, whereas Bolivia is the blue temperature line. So Concepcion, higher temperatures, that makes sense. It's at a lower elevation. So if you go down the bottom, you see 490 meters, or 1608 feet above sea level, compared to La Paz, which is at a much higher elevation and thus cooler temperature. Now our third key control for temperature would be cloud cover. We talked about this beforehand, looking at insolation at Earth's surface. So what's happening there along the red line is that dense band of water vapor, that dense belt of clouds, which predominates over the equator, which then is going to prevent incoming solar radiation from reaching the surface. Now this takes us back to what we've already talked about in a previous video lecture, cloud cover, and the role of clouds as far as moderating temperatures throughout the day, throughout the year, what have you. So we have the role of day clouds, but also the role of night clouds. So I ask you, critical thinkers, here's a map that shows global temperature range. And so those places that have a biggest range from their January to their June temperature, so that if they have a big difference between those extremes, January and June, then you're going to see it being a darker color. And even in some places you have a gray or green. But if you look at Africa, we've got both the Kalahari and the Sahara, which for the most part have a situation where there's a bigger temperature range. over those various places. I ask you, critical thinkers, what's going on there? To help you out even more regarding thinking about what's happening there in the Sahara, the highest temperature ever recorded is not anywhere really near the equator. The equator goes right through the middle of Africa, and here we are near the northern tip of Africa. And so what's happening here is the absence of cloud cover. So because there's no cloud cover, there's nothing that's going to block incoming solar radiation. So during those summer months, during that time where the subsolar point's very, very close to Al-Zizia, Libya here, we have no cloud cover, and so that incoming solar radiation is screaming through the atmosphere and is going to heat up the surface quite quickly. But once again, it's going to have, because of no clouds at night, it's going to have very, very cool temperatures. We'll talk more about this when we talk about climate of the Middle East a little bit later in the semester. But if you think about one of the things you would experience in the Middle East is extremely high temperatures during the day, but actually really, really cool temperatures at night, and that's all related to cloud cover. Going forward, video lecture 2.7, we're going to find out, well, what's the deal here? Here's a black line that illustrates latitude. So here we have essentially going through London, England, we have this line of latitude. But if we go right across, about to where Montreal is, it's a much different climate type. It's a much cooler temperature we would expect. So although latitude plays a key role, it doesn't really play a key role here. So that's going to be the focus of video lecture 2.7.